So guys, this is the video where I'm going to explain the rest of equilibrium for you guys. However, there's one thing that I want you guys to realize. In the lesson, we talked about um, temperature and how temperature affects it. So if forward is exo and backward is endo, then if we increase temperature into surroundings, we want to use that increased temperature. So we're going to favor the endo reaction. So equilibrium will shift backwards as the backward reaction is endothermic. Another thing that you guys need to realize is rate of reactions. So when dealing with equilibrium reactions, we're always balancing rate, right? So let's say I'm trying to produce C, cool? And producing C requires producing C is an exothermic reaction, so I need low temperatures. However, low temperatures will cause a slower rate of reaction because high temperatures and high pressures means higher rate. So although I will get less C, I might still increase the temperature, even though increasing will shift endothermic reactions because I want a high rate of reaction. So maybe write in your notes that when justifying a conditions, or when, because you'll get questions that are like, why did they use this condition? Even though this condition may lead to less of what we want being made or a smaller yield, that's the word you should use, we sometimes prioritize rate of reaction. Anyways, moving on, I've already explained to you the endothermic side of stuff, the temperature side of stuff, which is this part. And as you can see, as temperature increases, time taken to reach equilibrium or rate of reaction increases, time taken decreases. If the time taken to reach equilibrium decreases, that means my rate of reaction increases. But you guys should use this word when it comes to equilibrium. You should use time taken to reach equilibrium and don't use rate of reaction. It's just better, right? Now, to move on to the other two rules, pressure, concentration, and catalysts. I'll start off with catalysts. What are catalysts? Let's say this reaction is going on. All what a catalyst does is it increases the rate of reaction. Cool? But here's the deal. It increases the forward rate equal to the backward rate. So it might double the forward rate, but double the backward rate. So even though our rate of reactions have increased, and even though the time taken to reach equilibrium has decreased, because we're reaching it faster, there is going to be no change in the amount of A and B and in the amount of C's, because the amount going forward has increased and the amount going backward has increased by the same amount. So catalyst increase the rate of reaction, so they decrease the time taken to reach equilibrium. However, they do not affect the reaction at all or the yield. That's catalysts done. Now, as for pressure, pressure just means the amount of gas particles in a volume. And remember what I told you, equilibrium is like police. If I change something, it's going to try and change it back. So let's say I increase pressure. Increasing pressure means more gas particles. Cool? So what's equilibrium going to try and do? It's going to try and create less gas particles, because we don't want that many gas particles in here. We've increased pressure, we want to decrease it back. Well, okay, let's see how many moles of gas I have over here and how many moles of gas I have over here. Well, I have 2 over here and 1 over here, therefore I have 3 over here. While over here I have 1. Okay. So equilibrium will shift forward because less gas molecules are being made, so pressure will decrease. That is if I increase pressure. And likewise, if I lower pressure, so there aren't that many gas molecules, equilibrium will shift backwards because there are more molecules being made, so we'll increase the pressure right back up. I hope that makes sense. And higher pressure does mean higher rate of reaction, so lower time to reach equilibrium. Again, moves towards the side of the balanced equation with fewer molecules. So that's the rule for pressure. And higher pressure means more particles colliding with each other, which means higher rate of reaction, so lower time to reach equilibrium. Remember how I told you equilibrium is that state where the concentrations doesn't change? If we have a higher rate of reaction, we reach that state quicker. That's the idea. And then our last thing is adding concentration. This one's very simple. This is the idea. If I add a lot of A, like I take a jug of A and add it to my reaction, I have now too much A. So equilibrium will shift forward so we can use up some of this added A. And therefore we'll make more C. That's how it works. If I add B, it will shift forward to use up the added B. If I add C, it will shift backward so it can use up the added C. So as you can see in the book, it literally says the equilibrium moves away from the reacting substance in the balance equation. Reacting substance is the bad thing to say here. It moves away from the added substance. If I add A, it's going to move away from A, go forward. If I add C, it's going to move away from C, go backward. If I add B, it's going to move away from B and go forward. And obviously, if you add the concentration, you're adding the amount of particles, so more collisions can happen. Therefore, rate of reaction increases and time taken to reach equilibrium decreases. And that is basically equilibrium. The next page focuses on this whole idea of balancing an argument. So in an argument about conditions for equilibrium, you have to take into account yield. This is where you talk about equilibrium, how it shifts, and what we're making. You have to add in pressure. You have to add in costs, which come from temperature and pressure. Temperature and pressure are very expensive. So getting high temperatures and high pressures is extremely expensive. So we need to add costs into account, and we need to add out rate of reaction. At the end of the day, if your reaction's super slow in an industry, it's going to take too long to make your product and you're not going to be able to make it for the demand. So you need to take these three into account. So let's take, for example, ammonia. Ammonia in the Haber process is made with 200 atmosphere and 450 degrees. And they add in, let's say they add in an iron catalyst. Okay, well, first of all, you have 2 marks where you talk about the catalyst. You always state that the catalyst doesn't change the yield. As I told you, catalyst doesn't change anything because it increases the rate of forward and backward equally. However, it causes a faster rate of reaction, which means we will reach our equilibrium, time taken to reach equilibrium will be smaller because we'll reach that equilibrium state quicker. So catalysts are good because they don't get used up. Oh yeah, another thing, they don't get used up. Write those 3 things. They increase the rate of reaction, so time taken to reach equilibrium is smaller. They don't change the yield or whatever is made, and they don't get used up, so you can use them forever. That's 2 or 3 marks out of your 6 marker. The other 2 marks is to talk about how pressure and temperature will affect it. Well, here is our Haber process, right? As we can see, we're trying to make ammonium. There is 2 moles over here and 4 moles over here. So by having 200 atmosphere, that's a very high pressure, we're going to favor a side with less gas molecules. Well, there's 4 over here and 2 over here. So we're going to favor the forward reaction. Therefore, we're going to make more ammonia. So that's really good. As well as that, the pressure, high pressure means higher rate of reaction, so lower time to reach equilibrium. These are very repetitive. And then let's say the forward reaction was exothermic and the backward reaction was endothermic, then we have a problem. Because we have such a high temperature, 450 degrees, it will favor the backward reaction. So therefore, we'll have less yield of ammonia. However, that is a compromise we're willing to make because if we don't have a high temperature, we're going to have a low rate of reaction. Therefore, we won't produce enough products. Now, I've said some stuff that goes against each other. It doesn't matter. As long as you put down all these lists, you are good. So, main 3 things whenever you're comparing equilibrium. The yield, which is how equilibrium shifts based on pressure, temperature, concentration, whatever. Rate of reaction, which is based on the temperature, pressure, and catalyst. So temp, pressure, catalyst, and costs. This goes with temperature and pressure. Now, you might say something that, I didn't even mention it in mine, but so what a good mark will be, although this seems very good, the high temperature and pressure will cost the factory a lot of money. And that's basically the whole of equilibrium explained.